Vanishing cream, as the name suggests, it is derived from the name, from the fact that this cream does not leave any traces when it is applied onto the skin. So when you take this cream and when you apply on the skin, you feel as if the cream has vanished off. Actually, it does not get vanished off. What happens is it leaves a transparent layer, and hence you do not see, if you take a cold cream, or cold cream leaves behind a white layer, whereas a vanishing cream does not leave any traces, okay, when rubbed onto the skin. And that is why this cream is known as vanishing cream. The earlier name for vanishing cream was known as stearate creams. Okay, we are going to see that further also. So the first name was actually the stearate cream. Now Pond's company, you know this very well, these Pond's. Okay, now Pond's gave it a name as vanishing cream because it was called so, right? uh, Cold cream is water in oil type of emulsion, whereas your vanishing cream is oil in water type of emulsion. As I told you yesterday, creams are nothing but what? They are emulsions. Okay, all the cream, whenever the name cream comes, it means that it is going to have both the phases. It is going to have oily phase as well as it is going to have your water phase. Something more about the creams I just remember, so I've shared it with you. Now, creams are more preferred when it comes to cosmetics over the ointments. Gels definitely are preferred. Creams are preferred. Okay. In some cases, like when there are dentifrices, toothpaste, okay, are there. But mostly, whenever it comes to cosmetics, creams are the most ideal. What you call that? Formulation that are preferred. The reason being because if you take ointment, I said that ointments are oily in nature, okay, and oily preparations are that not that much cosmetically accepted. So whenever we have to apply oil onto the body, okay, they are basically applied in the form of the creams. Okay, as I said, they are cosmetically more acceptable. One more fact about vanishing cream is vanishing cream, as I told you, is oil in water kind of an emulsion. So where water is your continuous phase and oil is dispersed into it. That is what you mean by oil in water kind of emulsion. So as it is oil in water kind of emulsion and as water is a continuous phase, hence these vanishing creams get easily washed off when you are going to apply water to it. So removal of vanishing cream is very easier as compared to cold creams, because in cold creams oil is the continuous phase. It is water in oil kind of an emulsion, and you know very well oils are very difficult to be removed. Hence your vanishing creams can be easily washed out as compared to your cold creams. Uses of vanishing cream, definitely it is used in case of loss of moisture for dry skin. In case of dehydration, they have been used. Okay, another major use of your vanishing cream is it is used as an adhesive for your makeup powders. When you apply this vanishing cream, they get vanished off, right? But they leave a layer of oil, okay, onto the skin, which is not visible again. Okay, so they leave us what you call that, a slight layer of oil onto the skin. So when you apply facial powders onto it, your normal talcum powder, if you apply to it, then these talcum powder, these facial powders, they tend to adhere on the skin. Another advantage is that this vanishing cream forms a layer. So you have a skin, your vanishing cream, it forms a layer onto the skin. So if this is a vanishing cream, it forms a layer onto the skin, and then whatever makeup you apply upon it, it is not going to get transferred inside the skin. So makeup remains on the surface of this vanishing cream. Okay, so it acts as a what you call that, it acts as a base before applying the further makeup, right? And as I told you earlier, once you want to remove the makeup, you just, it can be easily removed because vanishing cream are easily washable. So once you use soap and water, this layer it goes off, this layer of your vanishing cream it goes off. Along with it, whatever cosmetics that you have applied onto it, whatever the other makeups, maybe the rouges, maybe the colors, etc., which are done by the actors, etc., who perform on the stage. They have to apply a lot of makeup. Then that makeup can be easily removed from the skin. Okay, so it acts as an adhesive. It acts as the first step for the makeup, for applying the further makeups onto the skin. Next, it also smoothens the skin. On application, it smoothens the skin, and it keeps your skin very soft. Further, it prevents the skin from roughening and chapping. Okay. Again, as I told you, as it reduces the loss of moisture, it dehydrates your skin like your cold cream does. Hence, it is also going to prevent from the skin from roughening and chapping. So these are the uses of your vanishing cream. Moving ahead, as I told you earlier, that these creams were actually known as steroid creams. Okay, but later on, it started to be known as steroid creams because it contains stearic acid. Okay, but later on, and stearic acid is the most important ingredient. How this, your cold cream are known as borax, beeswax preparation. Okay, your vanishing cream are known as steroid preparations. Got it? But later on, this steroid cream was known as vanishing cream. This term was coined by Pons, and this is because, as I told you, because they seem to disappear when they spread on the skin. They seem to disappear. This word is important. They actually do not disappear, but you feel that they have disappeared from the skin. Okay, and this was the fact which was very appreciated by the customers. The customers appreciated this fact, and hence Pons changed the name from steroid cream, okay, vanishing creams. Chemically, why they are known as steroid creams? Because chemically, or the formula, it consists of stearic acid and it consists of an alkali. Okay, what kinds of alkali we are going to use, etc. What is the role of alkali? What is the role of the stearic acid? We are going to see further. It consists of a polyol also. Okay, polyols are the compounds which contains number of OH atoms. Okay, in their structures, they are polyol, polyalcoholic. Okay, for that polyol, this word has come, and it contains water. These are the four main important ingredients. Now let us see the role of stearic acid and alkali in vanishing cream. These alkalis, okay, that are present, alkalis that can be present are sodium carbonate, sodium bicarbonate, potassium carbonate, potassium bicarbonate, potassium hydroxide, sodium hydroxide. Okay, many alkalis have been tried, and many alkalis have given different results. Okay, we are going to see what are the results that are given by these alkalis and which alkali is mainly preferred. Okay, but what do these alkali do? These alkalis react with stearic acid. Okay, and they form the soap. You're also going to see further how is the reaction that is taking place, and this soap now functions as a emulsifier or emulsifying agent, right? Okay, so in case of cold cream, you are having borax and beeswax which were reacting together, and they were forming a soap, in situ soap, and that was used as a emulsifying agent. In vanishing cream, you are having stearic acid and alkali. They react together, they form a soap, and this is how the system of vanishing cream containing oil and water that is getting emulsified. Okay. Now you have polyols. I said the polyols are important. The polyol that is added is glycerine. What does it do is it helps to soften and it helps to protect the skin, right? Okay, so softening and protecting of skin is done by your glycerin. Moreover, it prevents the chapping of the skin. That is also done by your glycerin. Chapping is nothing but cracked or your flaky skin. जब भी आपका skin dry हो जाता है, it becomes white, it becomes cracked. Okay, and the skin becomes flaky in nature. That is nothing but the chapping of the skin. So it gives the softening to the skin, it protects the skin, and this all is done by preventing the chapping of the skin by providing the moisture. Okay, so it gives the moisturizing effect, or it also prevents the loss of moisture, and because of all this, your skin becomes totally softened and supple. One more thing, one more role of your glycerin is it acts as a humectant. Now, what are humectant? These are the ingredients which help to retain moisture into the preparation. So if you do not, if you have a tube, if you have a preparation, okay, and if you don't have humectant into it, then water may be lost from the preparation, and your preparation, which is usually semi-solid in nature, this preparation is now going to become what? It is going to become dry because of the loss of moisture. Okay, so your glycerin helps to uh, retain this moisture inside the preparation. Okay, humectants usually they attract moisture from the air. बराबर है कि नहीं? So it does not allow the moisture that is present inside the preparation to get liberated. More so ever when the preparation is packed in a wide mouth bottle. Okay, so when the preparation is packed in wide mouth bottle, and if you open the container, then whatever is moisture is present inside, it may get lost inside the atmosphere. Okay, and the preparation may become dry in nature. It may not remain semi-solid. Okay, it may become dry in nature. So this loss of moisture is being prevented by your humectant, which is glycerin that you have added over here. Glycerin, as I told you, has other roles also. It softens the skins also because of the things that I told you, and also acts as a humectant. So these are the two roles of your glycerin. Now, one more thing that you have to remember is this vanishing cream. It gives a sheen type of an appearance, okay, or pearly shine, pearl type of an appearance, okay, when applied onto the skin. This is because of the formation of sodium stearate. So if you have some sodium ion that is present in your formulation, then this sodium ion reacts with your stearates and it forms sodium stearate. This sodium stearate gives you different crystals, okay, something like this. So these are the different crystals that are formed of sodium stearate. So this is the figure of alpha 1 acid, okay, sodium stearate. The size is 10x size पे आपको इस तरह से दिखता है. So this is one type of crystal that is formed of sodium stearate. This is the second type of crystal that is formed of sodium stearate. You have the third type of crystals of sodium stearate, okay, and these are the fourth type of crystals of sodium stearate. So these all are the different crystals of sodium stearate that have been formed, okay, and these crystals usually gives the shiny appearance when this preparation is applied onto the skin. First of all, it vanishes off, okay, and whatever the layer remains onto the skin, it gives the shine. This shine is because of the reflectance of light which forms or which falls onto these crystals, and these crystals are nothing but sodium stearate. Okay, so this sodium stearate crystals gives the pearly shine appearance. Okay, when this preparation is applied onto the skin, they reflect or they refract the light that is being falling on, and they produce a sheen. Okay, and if it is absent, that is the sodium salt is absent, if the sodium stearate has been not there, then they are going to get disappeared. Okay, this theory was very opposite to that is proposed by Portius. Okay, now Portius is one of the very good cosmetic scientists. He has written many books on cosmetics. According to his theory, okay, he said that oleic acid is responsible for producing the sheen. Okay, so the formula containing oleic acid and sodium salt, they produce sheen. Whereas if this, as I told you, if the sodium salt was absent, the sodium ion was absent, it was not there in the formulation, then the sheen was not produced. So whatever was the Portius theory, that if it is written in some book that oleic acid is producing the sheen, okay, then it is wrong, because Portius theory was wrong when he said that oleic acid is producing the sheen, because in the absence of oleic acid, sheen is getting produced, but in the absence of sodium salt, the sheen is not getting produced. Okay, So that is about the sheen or shine that is being produced because of your vanishing cream. It has been basically produced because of your sodium stearate and not because of the oleic acid, which is there in some of the literatures, which has been mentioned in some of the literatures. Okay. Now these I told you earlier that these are the crystals of sodium stearate. Something about polyols. We have said that these polyols they help to retain the moisture. Absolutely right. But these polyols also have some disadvantages. When you apply vanishing cream, polyols also get applied onto the skin, and these polyols now absorb the moisture because they are humectants. What they do is they absorb the moisture. So you're applying vanishing cream. On that vanishing cream, you are applying powders, isn't it? And now what happens is this vanishing cream, because it contains polyol, it is going to absorb moisture from the air, and because of it, okay, what you are going to see, you are going to see spot because so it becomes wet in nature, so you are going to see spots because of this face powder, and hence many a time repowdering of it is necessary when you are applying a vanishing cream. So if you are taking vanishing cream, if you are applying face powder onto it, and if the quantity of polyols is too much, okay, then you may need to repowder, okay, after some moment of time. I told you that we are going to talk about alkalis, right? So two alkalis which were very commonly used was sodium soaps and the potassium soaps, right? That is sodium soaps which have been formed because of sodium hydroxide, and potassium soaps that have been formed because of potassium hydroxide. So sodium hydroxide was also tried, and potassium hydroxide was also tried as alkali. It was found that sodium salts, okay, producing sodium soaps, they produce harder creams, whereas potassium soaps which are being generated because of potassium hydroxide, they produce softer creams and the creams with good consistency. And due to this, potassium soaps are very highly recommended when you are preparing vanishing cream. So the vanishing cream formula, if you see, it consists of stearic acid, and the alkali that is being used is potassium hydroxide. Okay, that is the alkali that has been preferred, right? Earlier there were many other alkalis that were also being tried. As I told you, sodium bicarbonate, sodium carbonate, okay, potassium bicarbonate, potassium carbonate, okay, these alkalis were also tried out, and these alkalis when they were tried, it produced the vanishing cream which was very fluffy in nature, okay. It gave the snow like appearance, okay, or some foam like appearance, and hence your vanishing cream were also known as snow creams, okay. These were very highly acceptable because of the nature, because they were very fluffy in nature, they were very nice to handle, it used to give a very nice feeling, okay. So when carbonates and potassium and bicarbonates are used, okay, as alkalis instead of sodium salts and potassium salts, these the creams that were formed which were very fluffy in nature. Now some of the carbon dioxide that is formed gets released, some of the carbon dioxide that remains inside the preparation, and it gives that snow type of an appearance or foam type of an appearance to your preparation. But what happened was, unfortunately, after some time, if you pack it, it goes to the patient, okay, the patient opens the pack, and this carbon dioxide that is present inside the preparation, this carbon dioxide gets evaporated inside the atmosphere, and because of which, as the loss of carbon dioxide is there, the mixture, you can see it, usually the cream you feel as it has sink down. So you have a cream which is packed in this way, which is fluffy in nature, okay, which is very soft and fluffy in nature. After some days you will find that the cream has become in this way, okay. It is a very sturdy cream, okay, and it has gone to the what you call that, it has gone to the base, it has sink down to the base. So this type of appearance goes to the cream. The appearance which is over here like this, it becomes like this in nature, okay. So you feel as if the cream has sink down. So many a time, carbonates and bicarbonates are therefore not used in excess quantity in order to prepare the cream which is snowy in nature. It is gives a very good feeling, it gives a very good appearance, but then after some days as the cream sinks down, it does not give a good appearance, okay, to the patient, to the customer. Hence basically this carbonates and bicarbonates are being avoided as an alkali. So if you see, we have used many alkalis. Out of that, you can see potassium hydroxide is an alkali, okay, which is being most preferred, most favored ingredient, which is being used as alkali. Okay, so now you have stearic acid, you have potassium hydroxide, which is being used, okay, and you have as polyols, you are using glycerin and you are using water, right? Let us go to the formula now. So in the formula, it contains of stearic acid near about 17%. It contains potassium hydroxide, which is 0.5%. What are the role of these ingredients? As we talked about earlier, this alkali reacts with stearic acid to form a soap. The reaction that takes place is potassium hydroxide plus stearic acid. It gives potassium stearate plus water. This, if somebody is very much interested in molecular formula, you don't have to remember it. I won't be asking you in the examination, but if you the students who are very good in chemistry, who like chemistry, for them you have KOH plus, this is the acid, okay, this is the acid COOH, right? So this K is replacing this H to form the potassium stearate, right? This K is been replacing the H, and this H reacts with this OH to forms H2O, right? यहाँ का OH और यहाँ का H, it reacts to form your H2O. So you get potassium stearate, which acts as a soap. The next thing that has been added is potassium carbonate. Okay, what does this sodium carbonate? Now this sodium carbonate is going to be used for two reasons. Okay, one reason is to form the sodium stearate, if you remember, which gives crystals, right, and which gives the pearly shine. So it has been used for that, this sodium carbonate. And as I told you, carbonate, right? So what it is going to give? Carbonate is going to give the carbon dioxide, which is going to give that fluffy nature to your preparation. Okay, so this is the role of this sodium carbonate, two roles. Okay, but the quantity that is being used is very small, that is 0.5%. So it is not going to prepare that much snow kind of a cream. If this quantity is being increased, if you use sodium carbonate along with you use sodium bicarbonate, if these two are added, you can try it out in the lab, whereby you can add sodium bicarbonate to your preparation. Okay, you will see that the cream becomes very fluffy in nature. Then the next thing that you add is glycerin. As I told you, it is a polyol, right? It acts as many region. It softens the skin, it protects the skin, it prevents the chapping of the skin, and also it acts as a humectant. Okay, then you are adding water, which is acting as a water phase. Okay, and then you are adding alcohol. These alcohol are used basically to solubilize your protein, and also it is an addition to your glycerin, which is a all. Okay, this is also all, right? And they are adding a perfume, okay, for your aesthetic appeal, for increasing the aesthetic appeal. So this is the formula of your vanishing cream. As you can see over here, the quantity of water is very high, that is 71%. If you have seen the quantity of water in cold cream, it was 21%. Okay, or 20, I think so 20 or 25% हमने लिया हुआ है in the formula, whereas the quantity of water over here is near about 71%. So 50% more water than cold cream we are using. Hence these creams can be easily washed off. Okay, because the amount of water that is there present is more. Moving ahead with the preparation, as I told you yesterday, whenever it is cream, there are two phases. You have a oil phase and you have a water phase, right? Both the phases are heated up to 75 degrees Celsius, and both are added at this constant temperature. Okay, they are mixed together at constant temperature to form the cream. Now, what is the procedure? In the oily phase, you have stearic acid. You take stearic acid, you heat it up to 75 degrees Celsius. This becomes your oil phase. Your alkali phase consists of your so potassium hydroxide over there. So potassium hydroxide plus your water plus glycerin you take together. Again, you heat it up to 75 degrees Celsius. This becomes your alkali phase. Okay, aqueous phase, sorry. Now what you're going to do is you're going to add this alkali solution, okay, under continuous stirring to this stearic acid phase, to this oily phase, and you are going to go on doing the stirring. Here the quantity of water that you have used is 1/3 quantity of water. So आपका 71% water is there. Here you are using only 20 to 25% of water of that. Okay, so 20 to 25% of water is being used. A remaining water is still there. So you are going to go on stirring it till the primary emulsion has been formed. So what is a primary emulsion? A primary emulsion in case of cream is, you said that it has been formed when there are three things. When you get a white colored semi-solid preparation, which when you are stirring gives a clicking sound, isn't it? So when you see that, then you are going to say that the primary emulsion is been formed. After the formation of primary emulsion, what you are going to do is you are going to add remainder of water, okay, which is also heated to the same temperature, and then you are adding the remaining quantity of water to it, right? And you carry out the continuous stirring of it. Then you continue the stirring till the temperature drops to near about 40 degrees Celsius. At 40 degrees Celsius, when it reaches to the 40 degrees Celsius, you are going to add to it perfume which is already dissolved in water. You go on adding to it and you mix it. Once your cream is been formed, then you're going to evaluate it for weight variation, physical appearance, pH, viscosity, spreadability, and exudability.